Hi everyone, welcome back to your own YouTube channel Infinite Iteration. I hope you guys are learning new things from my videos that I post daily. So if you are learning new things, if you find my videos valuable, then I humbly request you to like it, comment on it, either good or bad, just provide a feedback, and also subscribe to my YouTube channel for further videos. So today we are going to discuss about operating system kernels. It's just a basic introduction video for kernels, and later we will discuss it deeply. And after this video we will going to discuss very important topic of OS, which is system calls. So stick to my channel, stick to my videos for further update. Okay, let's start with OS kernel. So first I will present you an analogy of OS kernel. OS is something from which the rest grows. It is like a seed, as you can see corn on the screen. So if we have one corn, we can produce the rest of the corn, like a whole plant. So it is the kernel analogy. So think of it as a kernel. So kernel is basically like an engine of a car in terms of OS. Like car has interior, exterior, tires, and steering and windows, everything. But OS is like an engine, like as you can say, brain of the car. So it is one of the first program loaded into the memory when a computer starts and remains there until the system is shut down. The kernel remains in the main memory and is not terminated until the system shuts down, and the kernel has control over everything in the system. One more analogy for kernel: think of it as a resource manager of a factory. Let's say we have a factory floor which can be considered as a hardware that contains all the machinery and raw materials. The workers are like applications of OS, and the kernel is the central factory manager. The worker cannot simply grab a machine and work on it. They need permission from factory manager. So factory manager controls over everything in the factory. So it acts as a resource manager, and think of it as the kernel of OS in computer systems. So before the kernel, developers coded actions directly, like they hard coded into bare metal programs. They directly contact the hardware. So, and kernel was introduced in 1969. Per Brink Hansen discovered it was easier to create a nucleus, like brain of a OS, and then build up an OS instead of converting existing OS to be compatible with new hardware. Is there a difference between OS and kernel? Yes. Kernel is the essential core. It's like an engine of OS, acting as a primary layer. We have different layers of kernel, and we will discuss in more detail, like when we discuss about protection rings and kernel layers. And we will also discuss kernel thread, user thread, kernel level thread, user level thread, kernel space, and user space. So let's come back to the topic. The kernel is the essential core of the operating system, acting as a primary layer of software. It directly communicates with the hardware. Operating system is just a system software. It's basically like provides you user interface to communicate with the hardware from the user. Is kernel mandatory? No, not at all. Before kernel we had some OS, but we had to communicate with the hardware directly, and it was very difficult task to do that. Kernel made it easy. Kernel could also increase by retaining small utility programs such as program loaders and debuggers in memory between applications. These programs gradually evolved into operating system kernels. And as I told you, accessing the hardware directly could be very complex. So kernel usually implement a set of hardware abstractions, and it is also for the security concerns of OS to have a kernel and different layers of kernel. Purpose of kernel: it determines which process, which is the next process on CPU, when and how long, monitors how much memory is being used to store, serve as an interpreter between hardware and processes, as I told you before, receive requests for service from the process via system calls. System calls we are gonna discuss in our later videos of this playlist. If the developers implement the kernel appropriately, it is out of sight of the user. It operates in its own area. Like I told you, we have user space, kernel thread, user thread, kernel level thread, user level thread. So we will discuss all of these important concepts of OS in later part of this playlist. The user space is the environment where the user sees files and web browser. These program communicates with the kernel using a system call interface. Functions of kernel: loading and managing less critical OS components such as device driver, organizing and managing threads. We have discussed threads in our previous videos. Scheduling which application can access and use the kernel. So we will discuss later when we talk about protection ring, about which have the privilege to access and which not. So it has different layer of protection rings and different layers. Deciding which non-protected user memory space each application process use, handling conflicts and errors, managing and optimizing hardware resources, managing accessing input-output devices such as keyboard, mouse, disk driver, USB ports, network adapters, and display. So here's a small self-test of what we have discussed in this video. Do you think kernel is necessary? Pause this video and answer it. And the second question is, what are its responsibilities? So we will discuss briefly about operating system loading. First, the BIOS run a bootloader. BIOS is the firmware. Is the first thing that runs when you turn on your computer. So BIOS runs a bootloader that checks the storage devices like HDD. Most commonly we have in our today's laptop or CPU, we have SSD, solid state device. Okay, so we have these storage devices. First it checks the designated storage devices. Once it locates the kernel, it loads into protected memory and hands the reins over the system, like it gives the overall control or complete control of the system to the kernel. The first thing kernel does is decompress itself, because it is a compressed file. So it decompresses itself and set up basic data structure in memory. The BIOS also passes information about the system hardware to the kernel, and it can load the appropriate drivers. Then kernel initializes devices, all the devices through device drivers. Then it loads any additional drivers required for hardwares like printers and scanner. This is all done so the operating system can finally start loading. Once all that is taken care of, the kernel hands control over to the user interface. Then only you can see the user interface of your Windows or any other Mac, any other operating system, which could be a graphical desktop or command line CLI command line interface. So here's a schematic of how booting process in your system work. First we power on our laptop or CPU, then we have BIOS, and we in this particular we have UEFI method. We send post requests, and it has some boot devices like storage devices or maybe a disk image, and then it goes to the bootloader, and then operating system is turned on and it directly connects to the kernel. Kernel has system processes and it has user space, and then you can see the user interface of your operating system. Or when you just turn on the kernel, turn on the system, in the back end this whole booting process works on. Okay, thank you so much guys for watching this video. I hope you learned something new today, and if you find my videos valuable and beneficial, then I humbly request you to please subscribe to my channel, like and comment on my video, either good or bad. Just provide a feedback. Thank you so much guys, and I'll see you next time. Bye bye.